In this experiment, we will familiarize with multiplexer, decoder, and adder ICs. The first part of this experiment is building a full adder using 8x1 multiplexers. We have to use two multiplexer ICs to implement the full adder. One multiplexer will generate some S output, and the other will generate the carry C output. In the multiplexer IC, A is the least significant bit and C is the most significant bit. The sum and carry outputs will be 0 when all the inputs are 0. The sum output will be 1 and carry output will be 0 when one of the inputs is 1. When two of the inputs are 1, the sum output will be 0 and carry will be 1. When all the three inputs are 1, the sum and carry will be 1. You can give all the possible conditions and verify the truth table. For the decoder, there are three inputs, A, B, and C, and the 7 outputs. Here, A is the least significant bit and C is the most significant bit. When the input is 0, 0, 0, 2y0 will be 0 and all others will be 1. When the input is 0, 0, 1, 2y1 will be 0 and all others 1 and so on. We can check all the possible input combinations and observe the output as shown. Next is the adder subtractor using a 4-bit adder IC 74283. For the adder subtractor circuit, there are two inputs, A and B. Of them are 4-bit numbers. The J1 switch is used to select between addition and subtraction. When it is 0, the operation will be addition. When it is 1, the operation will be subtraction. The outputs are S, which is 4-bit, S4 to S1, and carry C4. Plus 0 equals 0. 1 plus 0 equals 1. 1 plus 1 equals 2. 3 plus 1 equals 4. Similarly, we can check different input combinations. For subtraction, we will close the switch J1. Here, the carry output indicate the sign of the output. That means if the carry is 1, then output is positive. If the carry is 0, then the output is negative and the value is represented in 2's complemented form. 0 minus 0 equals 0. 8 minus 0 equals 8. 8 minus 1 equals 7. 8 minus 3 equals 5. Now check 0 minus 1. The output is minus 1. Here we can find the 2's complement representation of 1 in the output. Similarly, we can check different inputs and verify the corresponding outputs. In the next experiment, we are adding to BCD numbers. The result also should be in BCD form, such as each bit should be between 0 and 9. Here we are using a combination circuit which will add 6 to the sum of A and B when the output of the first adder is greater than 9. That means if the output is 1010, we'll add 0110 to make the output 0000 and carry 1. 1 plus 0 equals 1, 1 plus 1 equals 2, 9 plus 1 equals 1, 0, which is 10 in BCD. Now 9 plus 9 equals 1, 8, which is an 18 in BCD. Similarly, we can check different input combinations. For the hardware implementation, we are building the full adder using multiplexers. There are two multiplexers used in this circuit. The sum output is connected to indicator 7, and the carry output is connected to the indicator 3. The inputs are taken from switches 5, 6, and 7. 0, 0, 0, sum is 0, carry is 0. 0, 0, 1, sum is 1, carrying is 0. 0, 1, 0, sum is 1, carrying is 0. 0, 1, 1, sum is 0, carrying is 1. Similarly, we can give all possible combinations and verify the truth table. For the adder/subtractor, we use an additional input to select between addition and subtraction. For subtraction, b equals 1. The carry indicate the sign. If we calculate 1 minus 0, output will be plus 1. If we calculate 0 minus 1, output will be minus 1. Here the output is shown in the 2's complement form. Similarly, we can check different input combinations and verify the output. Next, we will check the decoder IC. There are 3 inputs and 8 outputs. The decoder used here is active low decoder. Here, the least significant bit A is connected to switch 7, B to 6, and C to 5. The outputs 2Y0 is connected to the indicator 7, 2Y1 to 6, 2Y2 to 5, and so on. When input is 0, 0, 0, 2Y0 is off and all others are on. When 0, 0, 1, then 2Y1 will be 0 and all others are 1. Similarly, we can give all the input combinations and verify the truth table.